This is the CS2420 course, and we are continuing on with our binary tree, our B-tree class. We're on the last method. We're going to use recursion to count how many nodes are in our tree. Since we're using recursion, we better get our helper method in there. Alright, so I'm going to come down to the bottom. I called it node count. I better copy this so I don't forget. I do need to make sure it's templated. And my node count, I do need my scope resolution operator. Don't let me forget that. I've done that like 3 times. Alright, so there is our node count method. Now this particular method is super easy because all we have to do is call our helper method. Now this will count it starting at the root. If we start counting at the root, then we can count every single node in the tree. So that's the node count is now done, and we're just going to modify this code to be our recursive node count. So here we need our current node, and we're going to get, actually I'm going to leave this in here for a sec. We're just going to modify that. Okay, so all I have to do is see if the node exists. If it is, I can count 1. If not, if it doesn't exist, I don't want to count anything. So if our current node exists, then that's where our logic is. If our current node does not exist, I'm going to return 0, do not count this node. Alright, because it doesn't exist. Okay, so for here, I want to return 1 to count the node that I am. This is the current node. But then I want to add that to all of the nodes to my right and all of the nodes to my left. I should say left first and then right, because that's usually the format of binary trees. So I'm going to count all of the nodes to cur left, and I'm calling it self, so it should go and count every node to the left, plus I want to add all of the nodes to cur right. And that should be it. No loop necessary, nothing. All I do is count plus 1, plus everything to the left, plus everything to the right. If it doesn't exist, we just return back 0, so it won't get counted in this statement. So that's just a traversal of the tree. That's actually a pre-order traversal of the tree because 1 represents the current node. So it doesn't matter where this 1 is, because if you add node count to the left plus node count to the right plus 1, it's the same thing as 1 plus node count to the left plus node count to the right. But what it's doing is it's going through and we're doing a pre-order, so it counts this one, then it returns plus the count of all of these. Well, the count of all of these is 4 plus itself is 5, so it's just going to go through and count every node for us. And that is it for our binary tree. Holy cow, it compiled on the first try. You can kind of see what it looks like. Here's our pre-order traversal of the tree. We know it's a pre-order, well, we don't know it's a pre-order traversal in the tree because we don't know what the values are, but if you look at the code you can. It will count the number of nodes, it passed all the tests. Now save this code, because for your challenge all you're going to be doing is using this code and adding a find and a delete method and a couple other methods for the challenge assignment for this unit. Good luck with that. Let us know if you need any help, and have a fun time programming your binary tree.